Hi friends, in this video I will cover the basic topics of vector calculus to be needed for understanding the electrodynamics course in B.Tech, BSc and other competitive exams like GATE and NET. I will discuss vector algebra, vector fields and vector operator del. The symbols and notations I will follow from Introduction to Electrodynamics book by Griffiths. As we know that there are certain quantities which has magnitude only, like mass, length, distance, and there are some quantities which have magnitude and direction both. These are known as vector quantities like displacement, velocity, force, etc. And they are denoted by an arrow. And the length of arrow is the magnitude and the direction is shown by arrowhead. If we have a vector A, then the minus a vector, negative a vector is in opposite direction. The magnitudes are same, but there is change in direction only. This is an example to show that a difference in the scalar quantity distance and a vector quantity displacement. Suppose a car travels 12 km towards east and then 6 km towards north. Then what is the distance traveled and displacement of the car in this journey? So a car is traveling from A to B in each direction 12 km and B to C 6 km. Then total distance covered by the car is 12 plus 6 equal to 18 km. Whereas the distance is from initial point to the end point like AC vector. So it is under root 12 square plus 6 square according to Pythagoras rule, and the displacement vector is the magnitude of this vector is 13 km and the direction for this vector will be theta, and the tan theta can be calculated by perpendicular divided by the base 6 by 12. So tan theta equal to 1 by 2. So theta can be we can find theta. There are certain rules for the vector algebra, like addition of two vectors will give us always a vector, whereas subtraction of two vectors will also give a vector always, but the product of two vectors can give us a scalar. For dot product, which is denoted by a dot, and a vector quantity for cross product or vector product, which is denoted by a symbol cross. Now we will discuss the dot product or scalar product, which is the product between two vectors denoted by dot. A vector dot B vector equal to the magnitude of A, the magnitude of B, and into cos theta, that is that angle between these two vectors. Dot product is commutative, means we can change the vector A with B. A dot B equal to B dot A. It is also distributive. A dot B plus C equal to A dot B plus A dot C. The law of cosine is also followed by the vectors, like it is followed in a triangle. Suppose we have a vector A and a vector B, then this vector C is equal to A vector minus B vector. So if we take the dot product of this vector with itself, so C dot C equal to A minus B dot A minus B, and it will give us A dot A minus A dot B minus B dot A plus B dot B. So A dot A equal to A magnitude square plus B magnitude square. A dot B and B dot A, it can be added minus 2A dot B cos theta. A dot B will give AB cos theta. So C square equal to A square plus B square minus 2AB cos theta, which is the cosine law for vectors. Now the cross product. In the case of cross product, if we have two vectors A cross B, it gives us a vector quantity which have the magnitude AB sine theta and the direction perpendicular to A and B, which is n cap direction. And the A cross B cross product can be found out. The simplest method is the determinant method, where the first row is the unit vectors I, J, K, cap. The second vector is the components of second vector AX, AY, AZ, and the third vector component BX, BY, BZ. So this is the determinant method to find out the cross product of two vectors. and the cross product of two vectors is not commutative, means A cross B is not equal to B cross A, and cross product is distributive. It is distributive as if it was in dot product. So A cross B plus C equal to A cross B plus A cross C. And the cross product of two vectors are zero vector if this angle is 0 degree or 180 degree. Also, the cross product of a vector with itself, it gives also zero vector. So zero vector is a null vector or a vector which have zero magnitude and arbitrary direction. Here we can see that vector A is like this, but zero vector is only it have this dot, and it can be have any direction, arbitrary direction, but it have zero magnitude. So it is zero vector. Now we have one example, so that find the angle between the face diagonals of a cube. As we know that a cube have six faces, so we can take any two faces. Like here we are taking the xz plane face and one face on yz plane. So the coordinates we have taken as origin 0 0 0, and for simplicity we are taking it as a unit cube, means all sides are of unit length. So if we take one vector, we know the two vectors, then we can easily find out the angle between these two vectors using the dot product rule. So one vector is A vector is between these 2 points 1 0 1 and 0 0 0. So vector can be found out 1 minus 0 x cap plus 0 minus 0 j cap plus 1 minus 0 k cap. So it will give x cap plus z cap, whereas this vector gives from 0 1 1 to 0 0 0, it will give us y cap plus z cap. So we have now two vectors, so we will have to take the dot product of these two vectors. A dot b will be x cap, here is no x cap, so it will be 0, with y cap 0 into 1, and third z cap and z cap 1 into 1, it will give us 1. Dot product of these two vectors is 1. The magnitude of A is equal to under root 1 plus 0 plus 1 under root 2. Similarly, magnitude of B equal to under root 2. So using this dot product rule, we have A dot B equal to AB cos theta. It is cos theta equal to 1 by 2. So it is theta equal to cos inverse 1 by 2, and cos inverse 1 by 2 is equal to, means theta equal to 60 degree. So this is how we can find out the angle between any two face diagonals. Similarly, if we have a question like find the angle between the body diagonals of a cube, as we know, we have assumed that this kind of cube OA, B, C, D, E, F, G. This is a cube of side A, and the coordinate of vertices started from 0 0 0 to A 0 0 and like this. So there are four diagonals OG, CF, AD and BE for this cube. So we can take the angle between any two diagonals. So let us take OG and AD. This OG is in red color and AD in this purple color. Then the vector OG is, we know the coordinates, so we know this vector. So A minus 0 I cap plus A minus 0 j cap plus A minus 0 k cap. So it will give us AI cap plus AJ cap plus AK cap. Similarly, we can also find the AD because we know the coordinates. AD equal to 0 minus AI cap plus A minus 0 j cap plus A minus 0 k cap. So it is minus AI plus AJ plus AK cap. So we can take the magnitude of these two vectors under root A square plus A square plus A square. It is A under root 3. Similarly, magnitude of AD is also A under root 3. And the dot product between these two vectors will be I, and I will give 1. I cap is 1. So A into minus A, that is minus A square plus A square plus A square, that is A square. A square and A square will be cancelled out. So this dot product is A square. Now we have to the scalar product or the dot product between two vectors OG dot AD equal to OG magnitude into AD magnitude into cos theta. So cos theta equal to this back product of those two vectors divided by their magnitude. And if we put all the values here, so theta equal to cos inverse a square by a root 3 into a root 3, that is cos inverse 1 by 3. So theta equal to 70.53 degree in this case. Now the triple product, for the triple product again we have a vector. We have seen that B cross C, the product of two vector is always a vector. So a third vector A can uh, will be dot product with this vector, and one is cross product with this vector. And this A dot B cross C, it gives us the volume of a cuboid or parallelepiped, which is A dot B cross C. So it is the volume of this cuboid. Whereas vector triple product, it for A with the B cross C, if we have the cross product with A cross B cross C, so it follow a rule BAC minus CAB. It can be remembered at back minus cap. So the order is important in this triple product. And for the for product of four vectors, again we can have dot product and cross product, where we can treat the third last two vectors as a third vector, and that we can follow the product rule for these. Now in case of electrodynamics, we can have some vectors which are very important, like position vector r, and displacement vector, and one another vector is uh, so we start with this, the position vector r. It is denoted by this r vector, and it is the displacement vector if we have the coordinates x, y, z, and from origin 0 0 0, this vector OP is known as the position vector r, which is x x cap plus y y cap plus z z cap, or x I cap plus y j cap plus z k cap. These are the unit vectors. X cap, y cap, and z cap are the unit vectors along x, y, and z directions. The magnitude of this is under root x square plus y square plus z square, and the unit vector is r cap equal to r vector divided by magnitude of r. So x x cap plus y cap plus z z cap divided by under root x square plus y square plus z square. The another important vector is the displacement vector. It is denoted by dl vector, and it is a small or infinitesimal displacement vector from 2 points x y z to x plus dx, y plus dy, and z plus dz. So it is denoted by dl vector equal to dx x cap plus dy y cap plus dz z cap. In some books it is also written as dr vector. So it is the displacement vector. It will be also used in later. Separation vector. In electrodynamics, we have to take 2 points always. One is source point, where we put some electric charges there, and the position vector of this is r prime, and there is a point where we need to find the field. So it is the field point. The position vector of field point is r. Then the vector separation vector is denoted by this curly r or scripted r, which is the difference in r vector minus r prime vector, and the unit vector will be when this separation vector curly r vector is denoted by divided by its magnitude. And in Cartesian coordinates, if the field point is x y z and source point is x prime y prime z prime, then this separation vector r vector is equal to x minus x cap x minus x prime x cap plus y minus y prime y cap plus z minus z prime z cap. This is the vector, and if we divide it by its magnitude, then it will give us the unit vector, unit separation vector. So this is how we can find out the separation vector. It is very useful also in electrodynamics course. This symbol is have a special meaning. This separation vector is curly R vector. Now we have some scalar and vector fields. Like we have field is a region in which any physical quantity, it depends on the coordinates of the observation point. It is called the field of that physical quantity. And there may be scalar or vector field, like the scalar and vector quantities were there. So in a scalar field, the magnitude of the scalar quantity, it depends on the coordinates of the observation point, and like this phi equal to phi, which depends on x, y, z. But direction is not important in scalar fields, like temperature, gravitational potential, electric potential. These are example of scalar fields. And in vector fields, it is the region in which the magnitude and the direction of any vector quantity, it depends on the coordinates of the observation point. The field is called the vector field, and it is denoted by a vector equal to a vector x, y, z. The coordinates and direction is also important in this case. So electric field intensity, magnetic field intensity, these are the vector fields. Now there are the partial derivatives are very important in this case of electrodynamics. So we will understand what is the difference in the ordinary and partial derivative. As we know that ordinary differentiation is denoted by df by dx, and partial differentiation is delta f by delta x, this curly d or delta. So ordinary differentiation means when we find the derivative with one variable only. If f is a function of x, so then df by dx is the derivative, and this derivative shows the slope of the graph f versus x. And in this first image we can see that when x is increasing, f is increasing very slowly, so it is a slow variation. Whereas in second case, if when x is increasing, f is increasing rapidly, so it is varying very rapidly. But in case of the partial derivative, the vector depends on more than one scalar variable, and the function can be differentiated with respect to one of the variable, keeping the other variables constant. Suppose a is a function of x, y, z, it is a vector quantity. So delta a by delta x will be partially differentiated by taking y and z as constant. Similarly, delta a by delta y, it will differentiate only the terms which contains y, but x and z will be treated as constant. And similarly, delta a by delta z. So these are delta a by delta x, delta a by delta y, and delta a by delta z. These are known as the partial derivatives. And this is an example to understand the partial differentiation. Suppose we have a function which is function of x and y, f equal to 2x to the power 7 plus 9xy. If we want to get the partial derivative with respect to x and with respect to y, suppose with respect delta f by delta x will be delta by delta x of this function plus delta, it will differentiate only the terms which contain x. So x to the power 7 will be 7x to the power 6, so it will be 2 into 7x to the power 6, so 14x to the power 6. Second term 9y will be treated as constant, only dx delta x by delta x is 1, so 14x to the power 6 plus 9y. Similarly, if we want to differentiate it with respect to y, partially differentiate with respect to y, then delta by delta y or partial differentiation with respect to y of this function. So first function do not have y, so it will be treated as constant, so it will give us 0, and second one will give us 9x into 1, that is 9x, so answer will be 9x. So this is how we follow the partial derivatives. And there is one important operator in this electrodynamics, that is known as the del or nebula. So it is a vector differential operator, and it is usually represented by the symbol this del reverse triangle. It is a reverse triangle symbol, and in Cartesian coordinates it is written as del equal to I times delta by delta x plus j times delta by delta y plus k times delta by delta z. And this operator del, which is not a vector but it is a vector operator, so it has a very significant role in electromagnetics. um, elect- we will discuss this vector operator del in next lecture, how we can find out the gradient, divergence and curl, and later in Maxwell equations how this del operator is used. So thanks for watching this video. If you have any query or suggestion, please write in comments. See you in next lecture, which will be based on uh, the physical significance of gradient, divergence and curl. Bye.